Good morning, everyone. Welcome in the second day of the 12th annual conference of the AASD. We will start our day with the MENA IDF workshop, Practical Diabetes Management. I would like to invite the following professors. Professor Nam Han Cho, IDF President-elect. Professor Nizar Albash, IDF MENA Chair. Professor Louise Gardat, IDF School of Diabetes.
Assalamu alaikum. Good morning, everybody. It is a pleasure to have you today in this workshop organized by the IDF MENA region and the AASD in Egypt. It's a pleasure to have you today to talk about diabetes management from a practical point of view. This could be a very interesting event because I know we talk a lot during the meeting, but going to practical steps, how to manage diabetes is very important for particularly young physicians. We are honored today to have our President-elect Nam Shu and our Vice President of the IDF, Louise Gardet, the President of Portuguese Diabetes Association, who share with us this activity. Well, actually, we'll try to be in some ways an interactive activity. So it's not only a presentation. You can stop us when you have a question or any comment. Maybe we are going to practical steps during our presentations. We want, at the end of the day, we'll get a very practical knowledge to help you to treat and manage diabetes in your daily practice. Thank you for coming. I will give the word to Professor Nam Shu.
Good morning. Dr. Niza rightly mentioned about the workshop that we're going to have this morning. But I'd like to ask you one question. What is practical? Who is this practical for? Is it for patient or the health provider? So this practical issue has to go two way around. Another thing is that all of you medical doctors who went medical school, you probably learned statistics, epidemiology. But even myself, I said, oh yeah, we learn. I just slipped through the class. I ended up majoring in preventive medicine, and then later I find out this is most important, the fact that the physician should know about it. So this is kind of thing we're going to talk about during this workshop. How you get the medical knowledge. The basic thing is the information has to come from each individual patient, right? How often you take note of it in an individual patient's condition, the background, and you re-evaluate them when they come back for medicine. How often you do that? We neglect that part. Second issue is when you have a good, proper patient's information, you form data. People say data analysis because data is important. Once you have a good data, not a trash, good data, you'll get a good information about the disease, right? Then what do we have? You have a good information about the disease. We have a new medical knowledge and we apply for it. And we've been mentioning this a lot for decades. Evidence-based medicine. Yes, this is based on the data. Then we change it to word to different way. Personalized medicine. But we never applied it at personal level. Now what are we using? New word. Precision medicine. Yeah, what is the precision? You have to go in the details of the patient information. This is kind of things we're going to talk about it. through the school, how to manage diabetes and so on. Lastly, I hate somebody say cure diabetes. Even patients said it, the professionals said it, I fired it. I said, you don't cure diabetes. How many, the cure means you go back to the normal, you don't have to take medicine anymore. You don't have to seek medical care anymore, correct? We are managing, properly managing diabetes. Okay? In order to manage properly manage diabetes or chronic condition, you need good data. And I'll be talking about this issue in my talk.
Good morning. As the director of the IDF Diabetes School, words. As you know, IDF is the objective to improve the quality of care in all the world. The IDF Diabetes School is a tool to arrive to these objectives. I hope it will be a good tool to you, all of you, and let's see. Oh, okay, thank you.
Oh, you done? Sorry.
So we can start today our presentations, and again, feel free to ask your questions when you have any of this. We can start first presentation. Professor Ines, do you have some comment you want to add? Of course, when we talk about anything prepared here, it's a huge effort from Professor Ines Shelton. Thank you.
We have another session today after the conference, okay, and tomorrow morning.
Okay. I have to present the first speaker for this session, Professor Namshu. He's going to talk of prevalence and risk factor of diabetes.
You don't have one. Okay, good. I step down from podium in order to close to you, so I want you to learn something about the prevalence and risk factors. You heard prevalence and risk factor every time you go to conference. That's the only time you hear it, but you don't hear this thing during your ordinary practice, right? But let me show you how we're going to apply this during your ordinary practice. Okay, so diabetes fact, you all know about it. We have so many people with diabetes and even at age over 20, 65. And Louis yesterday said every 3 seconds we have new cases developing somewhere outdoor. Actually, it's every 2 seconds. And every 6 seconds, one person dies from diabetes. And then cost of the management or care, diabetes, humongous. It just cannot count. This is direct cost. So we know the problem with the with the diabetes. And we know the figures in all over the world, and prevalence says and number says Asia is prone to a high risk of diabetes, and it is catching up by Africa. And I'm not going to go into detail here, so we're going to start with the figures. 11%, 12%. What does this mean to you? Is this meaning a lot to you? Africa, 4%. It is true fact or not? So a lot of times the prevalence, the figure, percentage is misleading us to the wrong direction. So you have to be carefully evaluate the background of the data, how it is coming, where is it coming from. So we all know the fact from Africa is underdiagnosed because of economical issue. We cannot detect enough people from Africa. So that's why it tended to showing low prevalences. But if you go to the high-income countries or countries where you have a better medical care, they started showing the higher prevalences. Based on this fact, we know there's a socio-economic status or the policy, health policy issues are different between the regions. And of course, 1 in 11 adults have diabetes by 2015, 40, it'll increase to 1 out of 10. So what is the big deal about one more increase in next 25 years? The important thing is, what is causing increase of this number? That's what we need to understand. Okay? So my question to you is, how to evaluate the status? Current status of disease. We all know the baseline number, based on the prevalence. Oh, diabetes is really serious, the non-communicable disease in the whole world. We know that. Everyone agrees with it, right? Anybody not agree? We all agree, right? So, why we are agreeing with this fact? My question. Because the prevalence, previous slide shows, oh, that's very high. 1 out of 10 people is affected by diabetes. But again, what is the prevalence? Why are we believing this number just like the God, our Allah says this, then you all believe it, right? Why are we believing it? This is only survey. Like I say, where is this survey coming from? Somebody's conducting it. Maybe they wrongly conducting a survey and come out with some figure. We are believing it because this is prevalence, what we're saying. So be careful what we are reporting. Even the IDF refers something, but always please question, is this true? What is the methodology coming from there? Okay? The next fact is incidence. This is the two things you need to know. You have to understand. Incidence is different. Prevalence is all the cases existing at point. Incidence is new case. This individual who did not have the diabetes, but they developed diabetes in 2017, living in Cairo, that person going into the numerator in calculating number. So incidence is very important. So if you refer prevalence as a survey, what is the current status of disease? Incidence is monitoring how this disease changes every day, every month, or every year. So it tells how well the practitioners are doing for the managing disease. So this gives more information than prevalence. Then last issue is, what if prevalence rises now, as it is at this point with the diabetes, right? Prevalence of diabetes increase every time we report the diabetes atlas that come out, right? Is this correct fact? Is this mean diabetes continues increasing it or not? This is my question to you. Anybody has answer to that? You want me to tell you the fact that I observed? Yes, prevalence is increasing it. It is very good that prevalence is increasing it. You're probably smart. Why this guy? Now I'm crazy this morning. Maybe drink some alcohol last night. This is good. But as long as incidence is not increasing it. The fact is based on existing incidence data, new case, it is plateauing, and high-income countries is dropping. Incidence, new case is dropping. But why the prevalence increase then? Because of all of you are doing good job. You're managing patient better, so they're not dying. You see? So prevalence is increasing. So this is good news. People say they're panicking. They say, oh my God, prevalence is continuously increasing. We still have a problem with diabetes. No. You have to look at what's behind. They're not dying. You have a good, you're taking care of your patient good way, so mortality is low, as well as morbidity, so prevalence is increasing it. But incidence stays. So you have to look at all this background to properly understand where we stand. So just don't believe in, yes.
Now, when we do a survey, we come with a number of newly diagnosed or already known diabetes.
Correct.
How can you look into this? The newly diagnosed during the survey and the already diabetics during the survey. How that can happen?
Okay. The existing one, the one already diagnosed one is prevalence. But when you say the instance, you have to give a period. January 1st to December 31st, something like that. That's what instance you call the period instance or point instance. There's different terminology. So it's this newly diagnosed one, purely new and old. So new and old steps, okay? So what can we do to stop diabetes tsunami? Is there any solution? Yes, there is a solution. But I cannot do that alone. All of you have to come together. Let me show you. I'm going to compare between Western Pacific, where I come from, and your region, see what is different and what can we learn from this prevalence, okay? If you look at the Western Pacific part, this is the range of the number of diabetes, percentage of diabetes. If you look at the right side bar, you have age here, x-axis age, and percentage. If you draw a line here, perfect, right? If you know the statistic correlation or coefficient, R equal probably 1, perfect, okay? So I'm going to convert this graph into different form. This is what it looks like if you draw the bar graph into line graph. So it sort of looks like S. So there's a significant increment in younger age group here to here, right? This is where most of the diabetes increased. So immediately we could say there's something going wrong in that age group. Okay? Then we draw the line just based on the low prevalence. If we go as this, not exposed to the risk factors, the condition make you to increase the probability of diabetes, then we should go this way. Then even go to the later part of the 70s, we should only expect 1 million people with diabetes. Instead, we're observing 53 more million people diagnosing with diabetes. That is due to risk factor over here. Okay? So, if we go to the expected rate in late 60s, 11.5%, we should observe that. But instead, almost 20%. Similarly, and this is excess number, we look at in a MENA region. You immediately notice that that pattern is different. If I draw the straight line, it'll go like this, and there's something extra number there, right? So if you do, I do the same thing, this is what you should expect. You should, in MENA region, you should only have 23 million people affected by diabetes, but instead you observed 35 million. This is excess due to the risk factors. So there's an important point right here. What if you overlap between Western Pacific region and MENA region? Here's the MENA region figures, Western Pacific region figures. Where's the difference in this graph? Younger age group, starting about late 30 to late 50. Major part of diabetes diagnosed in MENA region is in older age. What is it? What is different about this MENA region's risk factor and people living in Western Pacific? See, this is what we need to start cross-comparing risk factors. Then, utilizing those risk group, we identify the risk factors. Risk factor means a lot of people misunderstand about this risk means, oh, you smoking diabetes, you are 1.7 times greater risk for diabetes. Risk means probability, okay? Increasing a probability have a diagnosis with diabetes. That's what risk factors adds up. But if you add existing all the risk factors, accurately diagnosing diabetes is only 30%. So 70% is coming from somewhere we don't even know what is causing diabetes. So this is where we stand at this point. So I showed this slide before. Based on Korean study, this is what we found. And we have a relative risk. If you immediately know this is prospective study, instance data, it's not prevalence data, newly diagnosed ones. And this is showing the relative risk. And being a metabolic syndrome, you have a 55% increase, not SO 100%, to the whatever the fact equation comes out. If this equation shows detecting a diabetes 50%, of this 50%, this contribute small fraction. This is what it looks like, and you could see all these risk factors adding it to condition, IGT, IFG, tenfold increase, having a hypertension, his family history, 1.47 and so on. So this is what the risk factors looks like, and I'm going to go into the detail. So based on Korean data, this is a living urban area, economic growth. This is by 2010, the income, family income was close to 25,000 per year, US dollar. Now it's exceeding more than 30,000, but the prevalence of diabetes continues increasing, foretelling just economic growth, just like economic growth. Then, of course, IDF also rightly say that more diabetes occurring in a urban area. And there's another the true fact behind these figures. It's not because urbanization is causing diabetes. It is because people tend to live in an urban area, they have more access to going to the medical care or medical center, so they're seeking for disease, so more people diagnosed with it. Okay, prevalence of the instance of diabetes according to the metabolic factors. I'm not going to go into the detail, I'm just showing this is the kind of risk factor added to the probability of individuals developing diabetes. Okay, smoking status, again, many times in yesterday's lecture on and past smokers and less smoking 20, greater than 20, they are very similar. But this fact, the past one, you have to understand, it's not because of the smoking past caused the diabetes, because the reality on this part is people diagnosed with a communicable disease, they tended to change their habitual factors, then they stop smoking. Okay? So that's why it's statistically shown the relationship between. And hypertension, again, we show instead of the fact about this, the research was we tried to identify, say how many of the DM patients develop hypertension during the follow-up. But when we compare them, there's no difference between normal and normal glucose level and normal glycemia condition during the follow-up. But if you look at the other way around, compare the individual has a normal blood pressure beginning of the study and individuals who had hypertension, later on within the 14 years, 20.6% from normal tension group developed diabetes, whereas in hypertension group almost 40%, twofold increase. So clearly the hypertension is independent risk factor for diabetes. This is what we found. Again, here is the same model. We control all these factors and then try to demonstrate independent relationship. This is how it shows with the severe hypertension, they are 86% higher risk for developing diabetes in the future. Okay? Genetic variations. How many of you know that diabetes has the true gene which causes diabetes? Okay, here's the 7 genes we analyzed in our study. Look at the effector side. 1.13 to 1.35. But if you just look at ask patient, do you have a family history of diabetes? Effect size of 1.47. Why bother to go in here and spend so much money to the GWAS analysis? Useless. Don't do it. Okay? So I'm the one of the person who's totally going against the SMP study. So there's no single gene relate to diabetes. Diabetes gene environmental the related disease. Okay. So again, in a last study published in 16 in the Lancet Diabetes, again we found we found another glucose kinase gene. Look at the hazard ratio 1.27. Nothing is greater than 1.5. So there's no single gene related or multiple gene in fact to risk of diabetes. Okay? So there's another area. We know they are all existing there, but we're not properly applying this information. Okay? If you look at the individual's condition, beginning of our study started 2001 and 2002. It is still ongoing. We've been following this more than 10,000 subjects for 17 years now. They come to our clinic and then we evaluate their condition. Look at the beginning of the study, normal glucose tolerance, IFG, IGT, and both conditions. Just look at the red bar. How many of them developed diabetes during 12 years of follow-up? This is with the analyzed data within 12 years. Individual who showed IFG beginning of the study, 50% developed diabetes within 12 years. Same thing with IGT, but if you have both condition, more than 80% develop diabetes. Just knowing this person's the condition when they visited your hospital, your clinic, you could follow them. Yes. Mm-hmm. Mm-hmm.
The first one, the black one is normal glycemic are smaller percentage at the end. That means in some way the normal develop diabetes more, or what's happened? What does that mean exactly?
It is complicated slide, but that's why I just want you to look at it. It is in normal group, beginning of the study, normal glucose tolerance, okay? And they 60% still stayed normal within 12-year follow-up, okay? And about 5% develop IFG, and yellow one is IGT, about 15%. And both condition, again, 5%. This is the important part. In individual who had the normal glucose tolerance, but still about 15% develop diabetes. What does that mean? Within 12 years, little over 1% converted to diabetes. It clearly tells you that diabetes relate to the many other factors, even though they've shown the normal glucose tolerance. Within 12 years, something changed in their life and they become diabetes, okay? So, but in other condition, they are increment. So when you analyze, that's why we put this part as a 1 when you're comparing it, okay? Then you remove this much from these people, and this is truly relate to the risk factor, okay? But this time at the IFG IGT condition, okay? And then again, we show this fact, this is how it is increasing fast in IGT, so we need to look into this part. We've been saying that prevention. Actually, prevention is done. For diabetes, we need to go in prevention plus intervention. How many times you hear intervention issues in diabetes? Not that often, right? We need to go into intervention. Don't be too late. If there's somebody from the policymakers here, please allow the doctors prescribe 500 milligram of metformin to individual who has this condition. If we do that, we could reduce diabetes more than 50%. I mean, the newly diagnosed diabetes, okay? So this is what intervention needs to be done soon. So now I'm going to show you how we utilize these risk factors into your practice, okay? We create an assessment model. Remember those risk factors which cause increase the probability of having diabetes? So we put all this: living urban, 2 times risk, have a family history, 1.64 times risk, smoking, all that. And here is the modeling issue. Using this relative risk, we give a weight based on the importance of it in the individual, the risk factors. But this case, it was 2.11, so the weighted risk factor is 2, and so on. So adding all this number, then we'll do what you call ROC analysis. Then come out with the best value, gives the best sensitivity and specificity. For this case, the area is about 68%. This is fairly good when you do the clinical trials or clinical investigation. If it is an animal study, there's less noise, so that's even bigger. But the human study, more than 60% is very good. Okay, so based on this, we come out score, and this is what we have. This is what we utilizing using risk factors to come into practice. So when you come to our clinic or our university hospital, we don't draw blood. We give a piece of paper here and pen. You fill it in. Then this person's case, John Doe's case, living in a rural area, have a family history, no smoking, age group. You just check, no blood draw. You only need a paper and pencil. Then when you're checking, this person come up with a score of 14, which indicating this person falls in this category. So within 14 years, the probability of this individual to develop diabetes is almost 40%. So what do? This year, leave him alone. Maybe 2 years later, he comes back, maybe you draw blood, check their glucose, or do the oral glucose tolerance test. Right? So we detect them in an early stage. And we treat them or manage them with habitual the modification, diet modification, and so on. Okay? So this is why we call the pen and paper, that's all you need. Okay? We have a more precise model. This is clinical model. As you could see, there is information related to the blood values integrated into the model, so insulin sensitivity, ALT values, and so on, so on. Okay? Then again, you could see the curve, 76.1%. Why? Because you have a blood information went in, so the prediction power is greater than just using a pen and paper. Then use this again. This person, John Doe, come up with a probability of 86.5. Then what do? Immediately you perform the oral glucose tolerance test on this person. So this is how we utilizing risk factor and utilizing a prevalence incidence to better understand this is how it stands in your own country or in the region, and utilizing individuals' risk factors to manage their chronic condition. Okay, and of course that risk model has to revisit, remodify all the time because risk factor changes just like this. If we have a risk model, 10-year model, maybe those risk factors has a stronger impact would be involved in this model. If the individual risk factors go in this pattern, maybe little, and the risk factor which will cause develop diabetes in later part, none of those risk factors will be in the model, right? So you need to revisit your model every 10 years and come up with the perfect model to pre-detect diabetes within your countries. Thank you very much for your attention. This is my last one, and
do you have any question for the Professor now before proceeding to next presentation? No. If not,